Okay, so we continue our discussion on trees. So in this video we are going to look at a property of trees. Okay, the statement of the theorem reads as follows: a graph G with n vertices and n minus 1 edges and no cycles is connected. Okay, so if you have a graph with n vertices and n minus 1 edges, and if the graph it has no cycle, then it is connected. Okay, so let's go and prove this theorem. Okay, so let G be a graph with n vertices and n minus 1 edges. Okay, with n vertices and n minus 1 edges, and suppose that G has no cycles. Okay, so our goal is to prove that G is connected. Okay, so our goal is to prove that G is connected. Okay, so we are going to prove this by contradiction. So for the sake of getting a contradiction, we assume that G is disconnected. Okay, and we will go through some argument and we will reach a contradiction, and that says our assumption will be wrong. Okay, so for the sake of getting a contradiction, assume that G is disconnected. So if G is disconnected, then G will have more than one connected components. Okay, two or more connected components. Okay, so since we assume that G is disconnected, G consists of two or more connected components. And also we can see that these connected components is also without cycles. Okay, because we assume that this graph G has no cycles, so that says the connected components also do not have any cycles. So G consists of two or more connected components, and each component is also without a cycle. Okay, so that must be true, right? Because we started with a graph with no cycles. Okay, we assume that the graph is disconnected, so it means it could have two or more connected components. And since we assume that G has no cycles, okay, it connected component, it doesn't have any cycle. Okay, so without loss of generality, let's assume that this graph G has only two connected components. Okay, so let me write down what I said. So without loss of generality, okay, assume that G has two components. And let them be, say, G1 and G2. Okay, so this is our graph G, and it has two components. First component is G1 and another component is G2. Okay, so okay, let's consider two vertices. Okay, one here and another here. Okay, and let them be, say, u and v. Okay, so let u and v be two vertices in G, and this u is an element of the vertex set of the first component, and v belongs to the vertex set of the second component. Okay, so let's add a new edge between these two vertices. Okay, these two vertices in these two connected components, and let's see what is going to happen. Okay, so let's add an edge between this u and v, and let's call that edge E. Okay, so add an edge between those two vertices u and v. Okay, where u is in G1 and v is in G2. Okay, and here we can see that since there is no path between this u and v in our original graph, okay, now the graph is connected. Okay, and we added one more edge here. Okay, so we started with something like this. Okay, n vertices and n minus 1 edges. So we added one more edge, and number of edges in the newly constructed graph is n. Okay, so let's see what is going to happen there. And again, okay, each connected component is also okay, each connected component doesn't have any cycle. Okay, so that says, okay, since there is no path between this u and v in G, okay, adding this edge E, okay, it will not create a cycle, because in the original graph G, these two are disconnected, and we are adding this edge only. Okay, so the graph will become connected, but okay, it won't create a cycle. Okay, so let me write down what I said. So add an edge between this u and v, and let that edge be E. Okay, so add an edge E between u and v, and let that edge be, say, uv. Okay, so since there is no path between this u and v in G, adding this E, okay, it will not create a cycle. Okay, adding that edge E, okay, it will not create a cycle. Okay, and again we can see that once you add this edge between these two edges, originally we assumed something like, okay, we have only two connected components. Okay, when you add this edge, now we can see that the graph will become connected, and the number of edges is increased by 1. Okay, so thus, okay, G plus E. Okay, so this is the new graph that we obtained by adding that edge between u and v. Okay, where u and v are in those two connected components. Okay, thus G plus E is a connected it's a connected graph. Okay, and again we can see that it is also a tree here, right? Okay, G plus E is a connected graph, and it doesn't have any cycle. Okay, it is connected and it is acyclic, so okay, it is a tree. Thus G plus E is a connected graph. Okay, and moreover, okay, this connected graph G plus E is a tree because it is connected and acyclic. Okay, but the thing is that, okay, here it has n vertices, okay, of n and n edges, okay, and no. Okay, so that's the contradiction that we get here, right? So here we have this tree, and this tree has n vertices and n edges, okay, and again it doesn't have any cycle. But in the previous video we proved that, okay, in any graph, if the graph is a tree, okay, then if it has n vertices, then the number of edges will be n minus 1. Okay, so here in this graph G plus E we have this situation. We have n vertices and n edges, okay, and this graph is connected and it has no cycle, okay, and that is a tree, okay, but that is not possible, okay, and that's the contradiction here. Okay, so let me write down what I said. So this is a contradiction. Okay, so this contradicts the fact that a tree with n vertices has n minus 1 edges. So here we saw this thing, this graph G plus E, it is a connected and it's an acyclic graph. So it is a tree, and here, okay, G plus E, this graph has n vertices and n edges. Okay, so that is a contradiction to the fact that a tree with n vertices has n minus 1 edges. Okay, we proved this fact in a previous video. Okay, and that says, okay, we arrived here because of this assumption, right? We assumed that the graph is disconnected, okay, and since we are able to arrive at a contradiction that says the graph must be connected, okay, so hence our graph G is connected. Okay, so that's the proof. So here we showed, okay, this statement, a graph G with n vertices and n minus 1 edges and no cycles is connected. Okay.